start out with this one. I think this is very important. So Python is one of the object-oriented programming languages. It came from the 90s. As you know, OOP didn't get started until the advent of C++ back in 1978. I also teach C++ at PCC. So I know the history here a little bit. And then what happens is C++ evolves into and got very, very popular with Microsoft. So Microsoft is all written in C++. And they came out with their own Windows, right? Visual Studio, Visual something, right? Visual C++. And then C++ ran into memory management and its issues, and it's not very easy to use. So Python, and so Java became popular in the early 90s, that replacing a lot of the hardcore C++ into Java land. And Python, of course, came up during the interim, and this whole concept of OOP, object-oriented programming languages, persisted in Python, even though Python is completely different syntax-wise from both C, C++, and Java. Python is a interpreted languages. So basically, how this works is you have a Python file. The Python runs on a browser or on your machine. That Python file has code in it, and every single line of your code is interpreted, not compiled. So C++, Java, these are compiled languages, whereas Python is interpreted languages. So how does that do? How does your machine do that? Well, your machine has this Python runtime. Python runtime is a software that runs, that listens and checks your for your Python instructions. So from top to bottom, let's say if your line, your Python code has 10 lines, your interpreter is going to go through every single line, reading it as you are loading your code at the same time. Is being interpreted, okay, and translate. And that interpretation results in a translated bytecode. Bytecode is something, it's a whole bunch of ones and zeros that gets used and run by your machines. So if this bytecode says 1 + 1, then what's going to happen is your machine, when I say machine, I'm talking about your desktop or bare metals machines that interprets these ones and twos, that translates to 1 + 1, sees this 1 + 1 in lower level and execute it, right? The instruction goes to the CPU and out into your consoles. So that's what happens with Pythons. But anyway, in order for you to produce something that is meaningful, there's this thing called syntax. So you can think of a syntax as English grammar. You first learn how to speak English, and you're 3 years old, you're making grammatical mistakes. And that's what we call syntax, okay? So as a beginner programmers, we have to cope with the language, right? Not just the keywords or the words that constitute this language, but also the grammar, like what precedes the other. So there is a set of grammar they have to go by, which is very important. This is what we call syntax, okay? So syntax error is one of the most commonplace beginner errors. In this course, this is of paramount importance. If you write codes that do not run, that's why if you go to my assignments, you see if your code do not run 50%, right, gone. That's exactly it. So you got to make sure you cut and paste your code and run it somewhere else. Make sure it runs. Make sure that it is clear of syntax errors before submissions, okay? So anyway, so that is what we call syntax. And of course, there's also a whole bunch of other types of errors that we'll talk about that later on. So as you move on to selecting a mode of communication with your Python, one of the things you can do is, I am assuming, okay, at this point, most of you, maybe not all of you, have already downloaded or installed Python 3 on yours. Now, we're not using Python 2.27, okay? 2.27 was popular back in 2015, but then Python 3 came about. We have to use Python 3 for this class. Now, I don't really care if you're using Python 1.1, Python 3.11, 3.51, 3.72, right? As long as they're 3x, it should be fine, okay? There's not much differences from one to the other, but Python 3 and 2, there are huge differences. These are these are the major releases that happens every decades. Okay, so there's a huge difference between the decade-old Python 2 versus the concurrent, the modern Python 3. So we're using Python 3 here. Okay. Okay. Now, if you type in Python 3, you're going to see something like this. So what is this? This is what we call Python interactive shell. This Python 3 is going to take you into this. Usually you see 3 less than sign or greater than signs. This is the prompt that tells you that you are in this quote unquote interactive mode. So interactive mode is very interesting. This is kind of like your runtime Python environment. You know, the machine, the interpreter is already running. You're actually loading a Python interpreter in the back on your console, right? So you guys know this is a console, right? Console is CMD on Windows and it's terminal on Mac. So this runs your terminals here. And if you switch over to the other, I'll showcase this later on. Then, you know, this is essentially where you be entering your stuff, right? You'll be writing stuff here and then you hit enter, okay? And then you hit enter here. And that's gonna give you something. Now, that's one way to run your Python. I would say this is not the only way that you have to learn for this class, because this is the only thing that you do. You're not gonna pass this class. So we want to teach you how to write Python script too. So let me get going on this. Now, just remember this, okay? Now, how do you exit this mode? On my Mac, I use you know, Control-C, Control-D. So there's one way to kind of kill this interactive, but I think there's some keystrokes there on different machines at different mode that you can experiment with, but it's totally up to you. So this is kind of a shortcut to getting your interpreter to work with Python. So you can write a whole bunch of stuff there. Okay, so that is the Python interactive. I think there's more pages here. It'll show you how you can do things. So in this case, I think I illustrated this too on from last week. So you can write something as generic as x equals 1. So what is x? Well, x is a variable. Python is not strongly typed. It's actually what we call weakly typed. So we don't really care so much about the type of a variable. It's kind of like in JavaScript, you know, if you've done that. Very, very different from Java and C++, where you have to declare a type of a variable. But your type of the variable is actually inferred from this number that is on the right-hand side of your equation. This is not what we call equations, okay? This one is what we call assignments. But anyway, I'm going through 4 or 5 different concepts at the same time. My point is that you can evaluate. You can evaluate each. This is what we call statement. Each line here, represented in yellow, is what we call statement. So you can evaluate each statement by virtue of keying in this thing, which is called enter. Okay, enter is the enter key above on the right-hand side, below your delete button on your keyboard. So this is what gets evaluated one line at a time. This is what happens if you're running Python interactive. You get to evaluate one statement at a time. And that statement is whatever in yellow that you have here. And whatever you have in yellow is what we call expression. That entire expression, or I'm sorry, this is what we call statement. Statement is what gets evaluated here. So if you're doing a print x, then what's going to happen is this x is a variable that has a number associated with inside the memory. And that variable number starts with 1, and then you did x equals x plus 1. So you effectively incremented that variable to 2. So what's going to happen is you have 2 stored in this variable. And if you just print it, it'll print 2. Does that make sense? Okay, and the other way to exit, like I said before, without using control whatever, the keystroke, Control-C, Control-D, to exit, to force close your interactive, you can use exit function. This is what we call a function, okay? You can call this function globally available in your interactive to close out of your interactive. Okay, so this is one way to kind of run your Python code, okay? One line at a time. Unfortunately, not all of your program is only going to have just one line, right? So this is not good. This only evaluate one at a time, but it's cool because you can test some stuff very quickly on your browsers. Not your browser, your console applications, your terminals or your CMDs. Okay, so let's talk about what do we say? I don't know what this means. Okay, there's a couple of things that you have to recall. We talked about reserved keywords, right? So just like any English language, there's some reserved keywords that you can't change ever. Like you and I, right, signify two different things, entities, right? So in keywords, so these are what we call keywords. The same thing with Python as well. We're going to cover most of the variables and how we use variables, how we assign variables to create an expression and making up the entire statement, how the entire thing gets evaluated in the context of a reserved keyword in these chapters. So this is kind of the focus of what we're going to go through today. For Thursday, if we don't get to it, which is chapter 3, we're going to talk about logic. So vocabulary, sentence structure is kind of like your logic. What makes this a loop versus the other, and how to iterate, create some sort of computing agent to iterate through your sentence structures as a whole. And then the last part, story structure, is more about putting everything together. So putting both vocabulary and your logic, which is vocabulary is kind of like syntax, right? Sentence structure is syntax and logic. And then story structure is kind of like, let me just apply everything to this entire book, right? Now I know bits and pieces from these chapters and from these paragraphs in the chapters. Let me just put everything together. So that's kind of an element of Python, a general approach that I teach students how to tackle, right? A brand new programming language from the start. Okay, so that's what I wanted to say about this slide. Let me move on to the next one, which is, all right, so this might be a little daunting here. I will be slow. Actually, 7:49. Okay, so you see these 3 blocks of code. Okay, 3 blocks of code, actually 4 blocks. They have different, so the other is very nice. It changes color. So just remember, you have this color, which is Hulu color. This is the, I work for Hulu. So I like this color, green. This is another block. And this is actually what we call a control structure, okay? This control structure is a for loop. Control structure can also be a while loop. So basically what happens here is that you have some sort of iteration going on here, okay? So this iteration just keep going for, however many number of times needed, as many lines as there are in this handle. And this line here is what we call declarations. Usually they're kind of like a preamble, right? Before you get into the music, playing the whole music, you have a preamble. And then you have the actual, iterations of notes getting hit on. And then of course you have more of those in the second block of code. And after 2 control structures, so you have one here, right? You have another control structures here. So this is the second structure and this is the first one. Finally, you can print something. And the result from each of these block of code gives you something that you can count on. So that's pretty much it. You have to kind of run through the entire thing to get to what you need. And obviously, you can't really get to the second block of code until you're done with your count. This is what we call array, right? Getting everything in. So that way you can set up the second structure using basically the number of items that you have in this array to iterate this again. Okay, so what am I talking about here? So this is a kind of an overview of what a Python code kind of looks like. And of course, you might be wondering, what is this space right here? Oh, by the way, if you're joining for the very first time, upon entering, could you please mute yourself? This is actually for the benefit of the entire class, because I got a lot of complaints from students. If you're not muted by accident, I'm going to mute you just in case. Okay, I think everyone is muted. Okay, great. Yeah, because sometimes students are in noisy area, and if there are other noises chiming in, it will be very hard to hear. So thank you so much for that consideration. So, okay, what am I doing? Okay, so I think I'm done with this one. Oh, yes, there's one more thing I need to mention. So if you're wondering what this is actually what we call a tab, okay? So So do you guys know what a tab is? This is above your cap lock. That tab is in ASCII is what we call backsplash T. Okay, backsplash T depends on your platform. Sometimes has anywhere from 4 to 5 different spaces concatenated. If this is on Windows, that might be 4 spaces. If this is Mac, might be 5 spaces. But every platform is a little different as to its interpretation of backslash T. So this is a tab, right? So if you see indent, so this tab is also called indentation, right? So Python is actually indentation sensitive. This is very, very important because if you screw up indentations, in other languages, you see curly braces, right? So you might see a curly braces here and then closing curly braces here. Now, there is no such thing in Python, okay? If you do curly braces, you'd be writing something else. So no, Python uses indentation. So I need to stress this I'll probably keep stressing it every single sessions here. If you don't have these correct indentations, your Python is not going to run. Your interpreter actually looks at these tabs. You can't just create an arbitrary space. You have to create tabs. So Python interpreter actually looks at these indentations to determine the beginning and ending of any sequence of code, right? Let it be a control structure. Let it be a simple if and else statement. Tabbing indentation is very, very important, and it's very, very sensitive. Otherwise, your code is not going to run. So that said, you want to double check, okay, your code. Make sure that it compiles elsewhere as well before you submit them. Okay, any questions about this so far? Couple of keywords. Yeah, you do not want to create variables using these names, okay? And of course, you don't have to memorize it, but just bear in mind, though, if you use an IDE, these keywords typically show up in different colors. So that is your safeguard right there. If not, then good luck. Okay, so let me just define a couple things before we get started with the next chapters. First of all is the terms that we use. So X is a variable, okay? So what is a variable? Variable is an occupied memory space. Variable has two things. One is its memory address, obviously, because if there is no memory address associated with this variable is not going to have anything, right? So in computer science, in order to create a variable that holds a value, that variable has to occupy some memory space. So you know this variable is occupying some memory space. So a computer has some capability to store some values to it. So this value turns out to be 2 in this case. So what is 2? 2 is a constant. Is a number, is a value that you're, or some sort of quote unquote label, right? That you're attaching to your variable. And then what's happening is you have operators. So these operators, sometimes a collection of operators forms in what we call expression. So this x plus 2 is actually what we call an expressions in computer science. When you have an equal sign, right? Equal sign means assignment. So this entire thing is assigned to this variable, right? The conclusion or the outcome of x plus 2, whatever that value is now evaluated. And the reason why this is evaluated is because what you have is an expression. X plus 2 is an expression. So every expression is evaluated before the assignment. So x plus 2 is evaluated before the assignment, which is cool because x now has the most up-to-date. And then print. Print is a function, okay? So in certain circumstances, we call these functions methods. There's actually a difference between the two. But in the context of a global facility that takes some sort of input that gives you an output, this input is x. Now this is what we call function, okay? So print is actually a global function that takes an input, which is a variable, and prints it. What is the output? It prints, okay? It outputs whatever this is to your console application. So your console, in this case, could be a terminal, or it could be an IDE that runs on your computers, okay? So it depends on how this is hooked up. Any questions about this? We're gonna go through this in details in chapter 2. So right now we're still on chapter 1, okay? All right, I'm just gonna skip through it. I mean, this is all Python interactive. Okay, so here's another thing. So we introduced Python interactive, but that one is not very useful. That one only writes one line at a time. So what you need to do is write some Python code that that you can save in some sort of py file, right? Some like your homework assignment, you have your name and then .py. So that's what we call. That's what the author call Python scripts. It's a collection of code that you can put into a single file. So that's it. I mean, it ends with a .py. If you have a different extension, I'm sorry, it's not going to run. So make sure that your extension is .py. Sometimes if you use a text editor to write your code, which is fine, okay? Some people do. Instead of using an IDE, they use text editor or maybe a notepad. When they save their stuff, they do .py, fine, but they forgot the extension is actually txt. So you ended up with whatever the file name, .py, .txt. That one is not going to run, okay? So you got to absolutely make sure that your extension for that file is .py. Okay, that's one thing I wanted to say about that one. And then the difference between interactive and script is kind of like explicit. If you go back to my online editor, the online editor allows you to write script. And that there's nothing interactive about that one. So you got to make sure that you do that. That way you can put a whole bunch of stuff into that one file and it all gets interpreted at the same time. Okay, program steps or program flow. This is something that we're going to talk about. Like I said, this is kind of the overview. We'll talk about control structures, and then that's how you can sequence these things in order. Sequential steps, you know, like I said, Python evaluation, just like any other codes, when you send in the entire script, it's happening, the evaluation happens from top to bottom and left to right, okay? So it's basically these directions, going top down and left to right. So that whole evaluation is true, regardless of which languages you're in. So interpreter actually goes through that directions to evaluating your code. So this is what the author meant by sequential steps. Okay, again, this is still high level. So let's move on to the next one, which is, I believe it's the control structures. Yeah, these are the control structure that are very, kind of like, I mean, you guys have taken, I don't know, I think many of you are in high school, but I believe in 7th grade or 8th grade, you are probably taught logic in math. And this is, you know, like control positive, control, or the reverse, like, what was it? De Morgan's law, right? So this is all logic. If this thing is true, right, then you evaluate this, right? And then you do something there. If this is not true, then don't do it, right? Or you can have if this condition number 1 and condition number 2 and, right, and condition number 2 are both true, right? So you have these conditional statements that you have to kind of evaluate. Same thing with logic, right? Or you can have an and relationship or relationship. It depends on what's on either side, right? So in this case, this one is singular. It's pretty easy to understand. It's basically saying if x, I'm sorry, let me use a different color here, red. If x is less than 10, then do this. What is this? Well, print. Print means printing this to a console. I want to print smaller to the console. Otherwise, I want to print bigger, okay? And then I want to print, I'm done, right, towards the end. So notice that there is indentations here, right? So if you don't have indentation, that means this entire thing is basically moot, okay? And there's a whole bunch of stuff that you have to remember, and that is that's the colon, right? The colon that you have to include. Otherwise, you're not going to have a syntactically correct code to compile, to interpret. And notice that Python doesn't require a semicolons here. Those of you who are using C, C++ or coding it in Java, even in JavaScript, to some extent, JavaScript doesn't require semicolons either. You might get used to it. You might not get used to it, but for Python, just get used to it. You don't need semicolons here, okay? All right, so that is our, probably one of the last few pages we have left. Let me just quickly skim through this. Repeat steps. Sure, these are control structures that shows you how you can iterate the steps from one to the other. And there's some in-depth anatomy of the entire thing. I think this is kind of moot because we're not gonna get to this level probably until week 2.5, okay? All right, so that is pretty much the completion of your overview of chapter 1, okay? Now, if you're still kind of rough on this, your responsibility for this one, I think, is important towards the latter half, which is what we just went through. If you have questions about anything else that we mentioned, go back to the video session from last Thursday, okay? I recorded the whole session, and that one is available in modules 1. Okay, so this one is good. Any questions about this one?